electrostatic potential.
All right, what's up, guys? We are making a video here today, live, listening to the GlobeBusters show. You can just tune in. I'm basically gonna be watching the show on my show, and so yeah, just stay if you like it, leave if you don't. This is the GlobeBusters' latest episode today. Light gravity, interferometry, and big cosmological problems is the title.
However, because the nucleus of atomic structures is roughly about 1,000 times more massive, right, than the charged particles around it, especially like the electrons and stuff like that, what it does is it gives a slight deformation atomically that becomes cumulatively over this chain of plus minus stuff. Okay, so before we do that, actually Iru just popped in, so let's say hi to Iru. And how you doing today, Iru?
Fine. Hello everyone in the chat. Hello hello to you guys on the show. So I just gonna keep a little bit quiet and trying to get into the subject, because I was outside with some minor issues with my grandmother. You know about it. Mm-hmm. So 92 years old. She has some difficulties in her health. So nothing. I just came from the hospital and I'm going to try to get into the show. So okay. Thank you everyone to having me on.
Okay, no problem. Well, I think I'd be doing really good if I lived anywhere near that. I'll be happy if I make it another 15 years, to be honest with you. But
yeah, exactly, man. Exactly. She's so well in terms of the brain. She's very conscious. But he suffered a problem in the hips. At that age is typically that you broke the hips. So it's just that. But she was in the hospital and blah 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 blah. So I don't want to interrupt it. I'm going to try to get into the subject.
Okay, sounds good. And also, shout out to Tristan711 says, can you talk about the mountain shadow casted up? Jaren, if you can remind me of that in a few minutes, we certainly do have an answer for that. That's a pretty easy answer, but we'll get to that after we cover this. So thank you, Tristan711, both for the super chat and the question. We'll see if we can get to that in a minute. But anyway, back to, also I saw another comment that somebody was not buying the acceleration from plus to minus to plus to minus. That isn't what's causing the acceleration. That's only how the dipole effect is stacking up. The acceleration is caused by the charge potential, not because of the molecular stacking. But I'm going to let Walt Thornhill talk about this a little bit more, and then I'll try and elaborate on it. We're not going to go too deeply into this because I've covered this many times before, and it is on several past episodes of GlobeBusters. But here's Walt Thornhill kind of giving an idea of how this electrostatic dipole effect causes gravity. Here we go.
So what causes gravity? The gravitational mass equals the inertial mass. That's lifting and pushing. So much the same mechanism is responsible for gravity. Now, atomic electrostatic dipoles, as I've talked about with the London force and so on, are formed by most atoms inside the Earth with the inner pole positive and the outer pole negative. The reason is that gravity is pulling on the nucleus. You can't shield gravity. That's the point. So the fact that the electron's down there doesn't matter so much, except that it holds the nucleus back from moving in the gravitational field. The nucleus is about 1,800 times heavier than the electron. So if it moves in the direction that gravity is pulling it, then the atom is distorted, as I've shown there, which means that the bottom end of that atom is more positive than the end nearest the surface, which is more negative, simply because the electron spends more time out at the top of the curve and a short amount of time at the bottom. So, the electric field produced within the atom distorts the subatomic particles. So, the particles within the atom, the nucleus and the electron, are all distorted similarly by a very tiny amount. And this is the distinction between the gravitational force and the electric force the amount of distortion is infinitesimal. 10 to the minus 38, 10 to the minus 39 times the gravitational force. So, it is the sum of all of the aligned subatomic dipoles that produces the profoundly weak force of gravity.
Nope. Thunderbolts project.
And the fact that they're held by the molecular forces, which is far stronger, means that the atom can't move, the nucleus just sits there and everything's in balance, but there is this weak electric dipole force which is transferred through the body.
Okay, so what Wall is saying then is that obviously it's not breaking the molecular bonds, but what it's doing is it's drawing the nucleus, which has a mass of roughly 1,000 plus times higher than the electrons orbiting it. It's drawing it down to cause an ever so slight distortion and bias downwards towards the Earth in all of these molecular constructs, the dipole alignment effect, or the plus minus plus minus plus minus. Obviously, this part doesn't change. The only thing that's being distorted slightly is the nucleus. Now, this is a very, very good theory, I think, and they elaborate on this very much, and I'll leave the links to this, but Wall actually goes much further in depth on this as to how this works. And it is so much more understandable and demonstrable in a lot of ways over gravity, because gravity is something that is absolutely...
They're doing a lot of great work.
Well, it's fictional as far as, mass attracting mass. We cannot detect any gravitational wave unless you want to buy the nonsense relativity-based LIGO, which gives you a chirp from an event that happened a long time ago in a galaxy far, far away. Utterly ridiculous, but we still can't detect any of these gravitational fields, from the moon or any other object right here in our local solar system. So this is actually much more demonstrable, much more understandable, much more realistic. I think it has it all over,
18
Einsteinian
plus,
or
guys,
Newtonian
18 plus.
gravimetric models, which
Turn
are
away
basically
from watching
based in fantasy, and like I said, Einstein himself was in doubt of his special relativity and general relativity, and Newton did not want to be associated with the idea that all of these masses were causing these attractions to each other. That got blown so far out of proportion that it was just utterly ridiculous. So, electricity is something that is demonstrable. It's something that is worked with daily. So is magnetism. And and all of these phenomena fit right into the very descriptions that we give gravity, including, people, the inverse force that it falls off with, right? It obeys very much the exact same, well, in fact, it's identical in formula to gravity, right? As far as how the power or the potential varies off with distance, right? So, anyway, that's all I'm going to say about this, but the bottom line is that gravity, whatever it is indeed a force, right? There has to be a force that is applied that causes this acceleration, right? You cannot have acceleration without a force, right? So density and buoyancy by themselves are not going to cut it. It just, there has to be something there that sets that initial bias potential for up from down. And I hope people understand that. But, those who go on and say, well, we don't need gravity because everything works fine with buoyancy and density. I'm sorry, it does not, because you cannot explain the acceleration that is taking place when you drop things from a very high place.
Interesting.
Any comments on this, guys?
Yeah,
that's actually very interesting, because when I was defending flat Earth, and more specifically gravity, those are things that I would jump to. Is if you watch my past videos, when we start talking about gravity, that's what I jump to, is buoyancy and density, which one I don't really have a great understanding of, and two, like they just said, there's more to it than I know.
Gravitational wave is great. Like shooting, like a wave. No, you are not able to do that. First of all, you need to define and prove that waves exist without a medium. So if the gravitational wave come 30 billion years away from the collapse or the crash of two black holes, and that is they trying to invent this nonsense theory about the space-time being like a fabric, or because they need a medium to propagate the wave, because the wave itself, it doesn't exist. It's just a concept. It's not it's like talking about information. I mean, there are just human concepts. There are not physical objects. So that is in terms of this wave thing about talking about the detection of gravity waves. So you need to show a wave, first of all, and you need to prove that you need to prove a medium to have that gravitational wave. And of course, in the theory of the outer space based on the heliocentric model, they talk about it's empty, it's without properties. So it's really difficult to conceive those notions. They trying to all the time to get confused that no, because it's the particle is the boson Higgs, or they change all the time of the ether. They're trying to change the concept of there is some kind of I don't know if it's a fluid thing out there propagating waves, or inside here. I mean,
this is great water, guys.
That is the first thing.
Essential water, no BPA or chlorine. Let me see if you can see this.
I forget the second thing, so I'm gonna leave to Jared.
BPA and chlorine free.
No, my pleasure, man. Go ahead. No,
And fluoride free. That's the biggest thing. No fucking fluoride. It's $12 a bottle, though.
Speak English, so that is why I leave you with the second thing.
Well, thank you very much for that. No, I mean, I need to look into this a little bit more, because even watching back what Bob just said already, I'll have to watch it again to see exactly what he means, because I'm somebody who still thinks that necessarily doesn't need to be a force, but based on what Bob just said, I'm now kind of changing my mind a little bit, so I'll have to watch that again.
Okay. Yeah, I remember the second thing. Was based on the acceleration. You need a force to have acceleration, and that is completely. I completely agree. But this is just a personal question, because we have the terminal velocity. Supposedly. I mean, you drop an object 100 kilometers up there, and if you can imagine that we have we can produce, we can take out of all the air to doesn't have any friction. It's gonna keep accelerating that object, or it's going to reach a terminal velocity where the acceleration is not anymore there.
Are you talking about in a vacuum or not?
Yeah, in the vacuum, not a vacuum, but supposedly, which humans can produce as a vacuum.
Well, this is alright.
It's gonna be
like the last little.
it's gonna. I mean, to leave clear the question, if I have an object 100 kilometers up, and I drop down, I leave that object fall in a vacuum, without any resistance, the object is going to keep accelerating its velocity, or it's going to reach this supposedly terminal velocity.
Yeah, me and this dude the other day were having a fucking discussion like till
Hold on, I think that
hella late about some government lying and shit.
I didn't ask a question.
That movie, Escape Room. I don't know if any of you guys have seen that, but that was deep as fuck.
Yep. So I guess
I feel like they were trying to say something in that movie.
Okay,
Yeah.
I don't think I got the question, but let me say what I was going to say about it.
Well, real quick, he was saying if he drops an item from 100 kilometers and in a vacuum,
it's a cool guy, man.
It's falling, will it continue to accelerate forever, or will it eventually reach a terminal velocity?
Well, the only thing, theoretically,
when I actually moved into this building,
it would accelerate forever.
he didn't follow the flat Earth conspiracies or anything. And it was actually, me and Hori, because when I had moved in, that was while Hori was had just flat spacked me, and I was now following Hori's work and learning from him. And so, I started showing him all the stuff that I was learning while I was discovering it. And at first, he was kind of annoyed, didn't want to hear it. But after every day, man, it started sticking. And now, that's all we really talk about is fucking flat Earth, government, all this shit. So that was a good flat smack at the house.
Pretty much, but we do have practical examples in the space jump experiment, where he accelerated past supersonic, and then once he got into the atmosphere, he started slowing down. Now, somebody made the comment in the chat that if you lift something up and drop it, you're the force. No, I disagree with that. You are not the force. The force is what's causing the acceleration once you do let go of that object. Sure, I can take something up to the top of a building, and that's me all the way taking it up there and letting it go. But something else is acting upon it for it to accelerate beyond the zero velocity when it leaves my hand to when it hits the ground. Now, the only other mitigating circumstances behind that is that if there is an atmosphere or water, right, that will slow down the descent of that, right, that would then define a terminal velocity. And obviously a terminal velocity in water would be different than it would be in air, depending on the viscosity of the medium. But for something to accelerate, it is a foregone conclusion and a scientific fact that a velocity must be applied to an object to cause an acceleration. Period. Okay, there's no arguing that. And that's why I'm saying that what that force is that's causing that acceleration is the electrostatic potential difference that is literally causing a static charge attraction, much like a magnetic charge attraction. Same thing with a magnet. You can have a big magnet in the middle, have like a metal object towards the outside, and if you let go of the object, it will start moving towards that magnet kind of slowly, depending on what the friction is, right? And then it will get to a point where it just goes whoop, bam, and it goes right to that magnet. In other words, it's accelerating into that magnet, right? And that force is the magnetic force. The same thing is happening with the electrostatic potential, right? Gravity has nothing, gravity as far as mass attracting mass is just stupid and it's out of the question. But things that we can define, which electromagnetic and electrostatic potentials, we know do exactly the same thing. And let's see, Youth says, GlobeBusters, what about densities falling in water? Falling at rates dependent on density. Vacuum chambers are used to hoax it. Well, yeah, that's exactly right. It's dependent on density to come up with that terminal velocity, right? But otherwise, under the circumstance of a vacuum, and even partially in an air or water environment, there is an initial acceleration from the time that you let that object go until it hits its so-called terminal velocity. Right? So that's my point. Go ahead.
And my question, maybe I know that I didn't elaborate so well, so thank you, Sharon, for translate my own English.
I'm always here for it.
Thank you, man. But my question is also based on the supposedly if you take a really heavy object that take away all the air. Supposedly we drop, you can imagine a tank, a war tank from a Panzer tank from 100 kilometers up. It has so much weight that is able to dissipate the air friction a lot, but it's going to reach a terminal velocity also.
In a vacuum?
No. I mean, even right now in our own setup world, it's like the example when you drop a book, a book, and a paper. Of course, the book is gonna fall much quickly than the paper because the paper has more air resistance. But if you put the paper, the sheet of paper on the top of the book and you drop it, both fall at the same time.
Right.
You follow me?
Right. Gotcha.
Okay. Now, if you drop a really heavy object from a plane 10 kilometers up, it's gonna reach also the terminal velocity.
Correct.
Even that this object had the property to go beyond the air friction, it's going to reach the terminal velocity. It's never going to pass that terminal velocity. It's never going to keep accelerating.
Right, because it's acting as an opposing force, precisely.
Okay.
Or I don't know if it's an opposing force so much as it is a resistance to the primary force. But regardless.
What I'm trying to say is, it's just a question. It's just, dropping my thoughts on the table. It's like you have a really heavy object, you drop it, start in zero velocity, keep, accelerating. So that object has the property to bypass the air friction because it's keep accelerating, but it's gonna reach a point that it's like there is no any acceleration going on. It's like reach that acceleration and stop. It's like something strange. If you have a really force accelerating on that, acting on that acceleration.
Right, exactly. And that force is ultimately being nullified by the resistive or the opposing, I don't want to say forces, but let's just say the resistance to it, the resistance of the air, okay? So, unless I'm missing something, am I missing something that you're trying to say here? Or,
No. Maybe I get confused. I confuse with my lack of language. But no. It's just that. I mean, for me, it's really something really strange that the object reach a terminal velocity, even that this object can. They have the property to bypass air friction.
Right, you're saying something really heavy, like a tank versus a ball, or a baseball or something, right?
Exactly. You have the initial conditions where this object bypass the friction because it's keep accelerating, but it's reach this terminal velocity and it stop accelerating.
right, and that's when the force is essentially offset by the resistance, okay? And that's what's actually happening. And theoretically, in a vacuum, it would continue to accelerate. To what level, I have no idea. But this gets into areas where I don't really want to speculate on it because we have no way to test it. Exactly.
Right, we can't do it. There's no way to make a never-ending vacuum. Now, they'll have you believe that space is that never-ending vacuum, but I don't believe that exists. There's no way that we can exist in a vacuum with the atmosphere attached to the Earth. And
there's no way.
Heard that argument many times. So that's why I think this gets into a little bit of a hypothetical or a thought experiment, because
Thank you, Jim.
If you're just going to believe in that vacuum, which again, I like what Mitchell from Australia said when he said if it wasn't for humans being here on Earth, that no vacuum would exist. And I tend to agree that the vacuum exists because we created it. They just want you to then believe that the outer space around us is also a vacuum, but I have no proof of that.
Right. Now think about this for a second, guys. And I just thought of this just now. But the ISS, right, or anything in orbit is technically falling around the object that it's orbiting, correct? Okay. So if there is nothing that causes a resistance, then the acceleration of gravity, even in whatever model you use, if it's bolting forward at 17,500 miles per hour, that must mean that at some point it also has to be falling at that speed. Now, since there is technically no atmosphere up there, why doesn't it keep accelerating beyond that 17,500 miles per hour and fall into the Earth, right? That's kind of an interesting thought, isn't it?
Or fly off into space, which is the same
fly
thing.
Off, yeah, exactly.
Right, which is the same thing for the Earth going around the sun, which is, why wouldn't it just fly off into space?
Right, but again, like I said, if there is an acceleration 9.8 meters per second squared, that means that every second that it's going up there, that velocity is being squared, which means unless they are compensating it by going forward, then theoretically at some point the velocity is going to be so high in a downward vertical direction that it seems to me that it would have to crash into the Earth. But,
right, well, that's why they have the curvature of space-time. That's why, though, because it has to be the cause of it. Otherwise, that would happen. So it needs to be that the mass is curving space-time and that things are falling within that curved space, the fabric of space-time.
All right, well, there you have it. Anyway, it's all bullshit. None of it makes any sense. Yeah. And but anyway, I did want to say that about gravity because, whatever gravity is, it is a thing, right? Whether it's caused by a mass attracting mass or electrostatic or electromagnetic potential, we all have our thoughts on that. But regardless of the fact, you cannot walk away. The one thing you cannot walk away from is that in order to have an acceleration, whether vertically, curvature-wise, whatever, linear, curvilinear, whatever, it requires a force to accelerate. And you cannot just drop something and say that there's not a force acting on it if it's going to keep accelerating, which, to some level we can demonstrate that. Like I said, Felix Baumgartner, and I tend to believe that was probably right, and it makes common sense, and that's the most important thing for me, is the common sense factor of it. So there you have it.
Well, yeah, I've always been somebody that believes just strongly in the relative density of it all, but now that you've worded it that way, I'll have to do a little bit of research on that and get back to you next week, because I can't argue with it right now. The way that you're saying, yeah, a force would require, or you would need a force in order for something to continue accelerating.
Correct.
So I'll have to think about that.
Yeah, and also maybe I'm wrong what I'm going to say, but the same thing that happened with mass. Mass is another concept. Nobody show mass, but what we understand as mass. It has this terminal velocity, and the same thing happened with the electromagnetic wave. I mean, when we talk about the speed of light,
All right, guys, I'm about to be
nobody
heading out in a
measured
minute.
the 300,000 kilometers per second. Nobody. They measure like 298.237 kilometers per second, because it has, this permeability and permeability situation when you trying to measure, electrical field or magnetic field. It has like a terminal velocity also. You never reach the 300,000 kilometers per second. That is supposedly, if here on Earth without a vacuum, this electromagnetic wave reach this velocity, almost 300,000 kilometers, supposedly it must be that in outer space, without any kind of resistance, it's going to reach the 300,000 kilometers per second. But nobody measured that.
Exactly.
We still measure under that number.
Yep. Yeah, exactly. And we have no vacuum chamber to even try and disprove or prove that. But really, if you start following the more, I guess, the different thinking on it, like the Ken Wheeler or some of the other people, where they talk about light is not a speed, it's not moving from one point to another, but it is a rate of induction that occurs between two polarized points, right? And then in this case, like I said, you've got the Earth as ground, you've got the firmament in my model or in my idea as the anode of this. And so what's happening is there is a rate of induction where this light essentially becomes manifest. It's not like it's traveling, it's simply becoming manifest, and it's a rate of induction through this ether, which a lot of people have a real hard time accepting, but is absolutely there. And of course that's a whole nother.
But if you launch a craft, supposedly, of course, at Mars, don't they just set it at, okay, we're going to burst into space at 55,000 miles per hour, whatever it is, and then the craft is supposedly supposed to maintain that 55,000 miles per hour through space on its way to Mars, correct? So right. I'm confused as to where we get this. If it's being attracted to Mars as to some sort, and this is just supposedly based on their model. If Mars is gravitationally attracting this craft, then why doesn't it also increase its speed at that rate? Well, or whatever. It wouldn't be the same. It wouldn't be 9.8 meters per second. I understand that, but wouldn't it have to increase speed as it moves along towards that?
Yes.
And theoretically, that is exactly what supposedly happened. Take Halley's Comet for an example, right? It goes out 50, 60 years in opposite direction, then finally slingshots back, and it's coming right at the sun. And it is accelerating all the time that it's coming towards the sun. Of course, why it's not accelerating directly at the sun is anybody's guess. But then the theory goes, as that comet is coming around, it makes a very close proximity pass to the sun at such a high velocity that it actually does not get drawn into the sun and the gravitational effect doesn't actually start drawing it to it until it goes past it and turns it around and slingshots it around the sun. So theoretically, yes, that is supposedly happening, Jaron. But in order to get out of Earth's gravitational pull, you have to be doing Mach 33, which is 25,000 miles per hour. And then, after that, whatever numbers they want to make up is what they're going to feed you. So, anyway, it's all such utter BS. I mean,
yeah, you try to tell a story based on their argument. So it's really difficult because
it becomes impossible. I hate to even think that way.
Exactly. If we have, some everybody calls ether, but for me, what is really impressive is that we have something that causes resistance to electromagnetic waves. So we have some kind of medium to propagate that property of electricity and magnetism.
Yes, exactly.
You can call ether, you can call whatever you want, but there is something up, inside of this plane of existence that interact with this, element of the nature, which is an electromagnetic wave. It doesn't exist light itself. When you see a light bulb, turning on, it is not light inside there. It's gas, which is, excited by electrical fields. But there is no light. In the nature outside, you have the same property when the lighting, lighting happen in the sky. Is the light that you see from a lighting is the gas in the atmosphere, which was exciting. There is no a thunderbolt, going in exist itself. I don't know if I know it. Today I have some trouble to explain myself, but there is nothing out there called light.
Right. And it's certainly, I seriously doubt it's a particle too. And I know some people would take some huge exception with that. But that's another discussion for another day, right?
Yeah. No, you have the from outside, the guy who like the history, Christian Huygens, determinate that there is supposedly a wave. It's not based on particles.
Yep, exactly.
But
so Bob, if they took a golf ball from the space station and threw it towards Earth, you're saying that it would accelerate all the way until it hit the atmosphere?
Yes.
At 9.8 meters per second squared?
Theoretically.
It wouldn't just maintain its given speed until it reached it?
Nope, it would be accelerated towards it because it has an attractive force on it. Now,
right, and I'm not sure that exists. That's kind of what I'm saying, is that I'm not sure. I think what happens here is that you've got this idea of space, which they want you to believe in, and so they've created a vacuum here on Earth, which is man-made. It's not natural, it's not nature-made, it's man-made. And then they're having the things perform in that vacuum in a limited space, and then trying to apply that to a make-believe medium.
Well, yeah, exactly. I mean, we're talking hypothetically here, obviously, because none of us believe that this outer space thing in the first place. I certainly don't, because I believe we're domed, we're covered. So no, there's no space in my. But if we're talking hypothetically, then hypothetically there is.
I'm gonna be heading out now. It was a great talk, guys. Definitely go catch the rest of that GlobeBusters episode. I think I already mentioned the name earlier. Yeah, it's a great episode. Catch it. Talking about some great stuff. I just gotta head out. Alright, guys. Have a good one.